Good morning and welcome. My name is Beth Capellis, and I'm the Sales and Support Manager here at Triangle Microworks. Welcome to our latest webinar, Tips and Techniques, Gateway Configuration Made Easy. Before we get started, I'd like to go over some housekeeping items while everyone is still joining. The webinar is scheduled to be 1 hour long. The audience is on mute, so please submit your questions online using the webinar toolbar under the section titled Questions. You can submit questions as soon as you have them. We will begin answering questions online as we have several engineers monitoring the questions and responding to them directly. We'll try to take a couple of breaks to read some of the submitted questions and are also happy to stay on after the webinar is over and answer as many questions as we can. With that, I'd like to introduce the folks behind the scenes that are answering those questions. Today, we have with us Cyril Vendetti, product developer with Triangle Microworks. We also have Fred Van Eyck, our senior product developer, specializing in our SCADA Data Gateway, also with Triangle Microworks. Next, I'd like to introduce our speakers. Today, we've got Matt Green. Matt is a senior application engineer at Triangle Microworks and brings over a decade of experience to the role. Matt serves as a technical trainer, providing direct customer support, conducting product demonstrations, providing one-on-one or group trainings, as well as hosting webinars. Additionally, Matt works as a quality assurance tester, specializing in the company's simulation tools and our gateway. Next, we have Jackson Moore, application engineer here at Triangle Microworks. Jackson received a Bachelor's of Science degrees in both electrical engineering and computer engineering from North Carolina State University, and he has a background in power systems engineering. Prior to joining Triangle Microworks, Jackson spent 5 years as a microgrid system engineer where he designed and developed load management control systems for multi-source microgrids. Currently, Jackson works with our customers and development team to understand and solve the challenges our clients face. So now that you know everyone, I'd like to give you a little bit of background on Triangle Microworks. We were established in 1994 and have over 28 years of communication protocol experience. We are headquartered in Raleigh, North Carolina, and have customers in over 70 countries. We work mostly with equipment manufacturers, electric utilities, and system integrators. The products we offer all support the standard SCADA protocols and fall into 3 categories. First category is source code libraries. We license source code directly to manufacturers for use in their devices and systems. This allows for a much faster time to market and greatly reduces their cost and development times. Licensing a source code library also includes support for your implementation and any issues that may arise in the field. We also provide testing tools supporting these libraries and protocols. These tools are used for communication testing in the lab or the field. They are designed to troubleshoot, simulate, and automate testing for both a single device or a complete substation. Lastly, we provide a SCADA Data Gateway, which is one of the main tools you'll be seeing here today. It's supported on both Linux and Windows for protocol translation and data concentration with standard SCADA protocols as well as OPC. It is available as software only or pre-installed on hardware. We are heavily involved in the standards committees that support SCADA protocols like UCA Group for 621A50 and DMP user and technical committees. Through our participation, we help define the protocols, stay up to date on the changes taking place, and ultimately provide feedback based on our customers' needs as the protocols continue to evolve. So now that you know a little bit more about Triangle, I'm going to go ahead and hand it over to Matt to kick off the webinar. Matt, I'll go ahead and make you presenter.
Thanks, Beth. So today we're going to be talking about gateways. This is the agenda for what we'll be looking at for the remainder of the webinar. I'm going to start by doing a brief slide or two about what a SCADA gateway is and what its basic functionalities are. After that, I will be going over, some of the basics that we've touched on, some of our previous content we've put out. We have several resources to help people understand gateways. and specifically our own SCADA Data Gateway. One of these resources was a previous webinar we did named Introduction to Gateways. The first part of this PowerPoint presentation will be to recap some of those major features of the previous webinar. Of course, if you want more extensive details on these topics, you can rewatch that or any of our other gateway-related content, especially our webinars on our YouTube channel. So I'll be talking about manually adding and mapping points from the RTUs and communicating that up into our gateway. I'll also be talking about cybersecurity and the enhancements that we have, including the user account and audit logging, and explaining kind of the differences between the different user roles when it comes to those cybersecurity, such as read-onlys, users, super users, configurators, things like that. After I'm done with the PowerPoint presentation, which is probably about 10 to 15 slides, we'll be moving on to the live demonstration that will be given by one of my colleagues, Jackson, who Beth introduced. We'll be talking about creating and mapping points again, but this time we'll be using some of the tools available to our SCADA Data Gateway to allow you to do that automatically. This is important. By automating this process, you can actually drastically decrease the configuration time of your gateway, especially for large configurations. We'll also be looking at equations, which include logical or mathematical processes to better view, report, and understand what's going on in your system. And then we'll probably get close to ending with talking about sequence of events, which is one way that you can log information out to a document that you can refer to later. So a typical gateway will have this type of structure. We'll be referring to a diagram like this or ones that are similar to this a few times throughout this presentation. It's worth taking a good look at this as it's a good place to start when it comes to foundational information for a gateway. So you'll see here this light blue square. This is our gateway. Above that, we have a control station. In this situation, it would be a DNP3 control station. This could also be a SCADA Master or possibly an HMI. Anything like that can be sent here as the recipient of the information from the gateway. You'll also see that there are RTUs. In this situation, again, it's a DNP3 outstation. All of this information will then be reported up to the gateway. So the question here is how can you get all of the data that is relevant and important from all the different RTUs spread across your substation or system into a single place for the end user to see, especially at a control station or externally. And that is the job of a gateway here. So gateways will typically have multiple network adapters and multiple IP addresses. So for example, you'll see Master 1, which hooks up to DNP3, Outstation 1 will be at a different IP address than Master 2 and Master 3. And all of that would be, say, on one logical network. So this would be like 192.168.1. Whereas typically the control station could be isolated to a different network to allow for segregation of different types of data. You'll also want to be able to run all of that through what we call the mapping logic here, which is in the middle. And what that mapping logic does is it allows you to pick and choose the important bits of information, maybe your class data, your report data, anything like that, can be all mapped up to the outstation, which is what is presented upward. So now let's talk about some of the functions you'd expect gateways to have. Not all gateways will have all of these functions, and you would expect a large percentage of them, though, to have at least one or multiple of these functions. The first one we're looking at today is the data concentration. That's actually what we were just looking at here. Data concentration is when you take data from across multiple different devices, and then you put it all through this mapping logic into a singular database, and then you can present that database up to your DNP3 or your control station, whatnot. So you're concentrating the data across your entire substation into a singular database, which you're presenting to your HMI or your SCADA Master. There's also protocol conversion. This is a feature that is where our gateway originally started out with. And what it will allow you to do is translate between protocols. So, for example, we could have a hypothetical substation that included both 61850 and Modbus RTUs monitoring the electrical equipment. But if your control station is expecting IEC 6870-5-104 traffic, there's obviously a mismatch there. So another thing a gateway could do is take the data from your Modbus and 61850 devices, go through the mapping logic, and map that to a database for the control center, the SCADA Master, to see. So not only do you map the protocol, but you can map the like types. So obviously, very simple example would be a 61850 Boolean probably would get mapped to the similar Boolean type in the 6870-5-104. But there are other things that the gateways could do, such as possibly condensing the data or scaling, doing scaling factors, or things like that can all be done during this protocol conversion step. Another function that you'd be looking for inside of a gateway is any sort of way to historically log data. That can be done through, external database servers that you export data to. Sequence of events is what I mentioned a little bit earlier. There's a lot of different ways that you want to be able to save that data off. And the important part about that is once you have that data off, you now have access to not only what's going on in your system right now, but if you know something went wrong previously, you should be able to drill down to what exactly happened during that time and try to isolate whatever the problem is. The fourth topic for the functions that I'll be going over today is security. This is becoming more and more important over the last few years. I'm sure you've heard of the rise of cyber attacks and things like that when it comes to basically anything that malicious people can try to get into and hold ransom or whatnot. So security is becoming much more important in the SCADA world. For both user control and for data. So data could be authentication or encryption, anything that makes it so it's your data is harder to intercept or do like a man-in-the-middle attack for. Whereas user would be, providing things like usernames or role protection or audit logging to allow you to, verify what's going on from the configuration point of view. And the last function that you could expect to see within a gateway would be any sort of local HMI functionality or setting alarms for people to look into. Basically just getting a localized quick warning if anything's going wrong to alert people to go and repair those or work on those or gather the information that you need to make informed decisions. So we're going to start on the webinar recap, the introduction to gateways. I've got a few slides here just to kind of catch you guys up. We demonstrated our SCADA Data Gateway. That is what we'll also call the SDG for short. SUG was built 20 some years ago. Like I mentioned earlier, it was set up to be originally just kind of a protocol translator. It was built off of all of our libraries that we still maintain and sell to this day. It grew over those 20 years to support IEC 61850, DNP3, ICCP, or also known as TASI2, IEC 6870-5-101, 103, 104, Modbus, and multiple flavors of OPC, including UA, Classic, and A&E. And our SCADA Data Gateway is used by customers all around the world, thousands of them. It's one of our most mature products. So let's talk about the basics of how you can interact with our gateway, specifically the SCADA Data Gateway. We've made it so that when you're configuring the devices, whether it be the client or masters that are pulling data in from the RTU or the databases that you're presenting to your control center, we have these built-in wizards, like over here on the right-hand side. These wizards will step you through the process of creating everything that is required for your device to be functional within the SCADA Data Gateway, including IP addresses, port numbers, specific namings you can put in there, any of the cybersecurity stuff such as TLS or encryption or authentication. This wizard will basically step you through the process of creating the device. Once you do that, you can then go to the device you created and add points to it. So for example, if you did create a DNP3 master, at this point you could add all of your binaries in individually or all of your analogs or whatnot. Some protocols even have an automatic feature where you just right click and do auto create tags. And what that'll do is reach out to your RTU, say, give me all your points, and it'll automatically populate all of that for you. Of course, now that you have that those placeholders for the data, you need to keep that data up to date. And that's what this action mask here is for. So following the example I was just talking about, we'll have a DNP3 master action mask. Well, the action mask is telling the gateway how you want to receive the data. Do you want it to pull it periodically every second? Are you enabling like unsolicited messages and getting them as it changes? Are you expecting, an integrity data pull every 24 hours? However you want to get the data in, you can configure the gateway to do. So for this example down here, you'll see I have it set to read class 1, class 2, and class 3 change events. And underneath it, you'll see that this action mask has a period, and you can do that every second, 2 seconds. Just make sure you keep up with the change events. So now we have all of the live information in our gateway. How do we either do a protocol translation or map that to a different database and concentrate it across multiple devices? Well, we tried to make that as easy as possible as well. So for example, you can go to, let's say I had this RTU client for 61850. You can go to the point that you're interested in, such as this MMXU, that is our measurement values. Just grab and drag and drop it where you'd like it to go. Once you do that, you'll go ahead and see the value is now mapped within your SCADA database being presented up to your control center. We tried to make it as easy as possible when looking at these databases that you're building up to know where the data is coming from. So you'll see right here in line, there's a column called mapping, and you'll see Bay controller, MMXU, all the way down to the path of where that came from. We also added these direction indicators with these red boxes around them, just to kind of point that out as I put that in the PowerPoint. This lets you know which way the data is basically flowing. So it's coming into our 61850 RTU's client, and then that value is going out into the mapping to our SCADA database. Or if you look at from the other configuration view, you see that the value from there is coming in to our SCADA database. We also support multiple mapping. So if you have 100 points, don't worry about dragging them individually one at a time. That can take a lot of time. You can actually just multi-select and drag them all at once and map them at once. We also spent some time talking about cybersecurity, as that is becoming more and more popular of a feature these days. The one that we're talking about right now is the user accounts. What the user accounts will allow you to do is limit your exposure if possible cybersecurity attacks do happen. So if you set up username, passwords, and roles for the people who will be interacting with your SCADA Data Gateway, you can give people who may only need to read information read-only permissions. This will prevent them from making any sort of mistakes or accidentally deleting something they shouldn't, and just lowering your risk there. But also, if you have these user accounts, you're lowering your exposure in case there is a data leak or someone gets access to an account they're not supposed to be able to. If everyone is an admin, then any account that gets leaked could be catastrophic. Whereas if you limit each individual account to its specific functionality and what it needs to be able to do, you are lowering your exposure there. Of course, we go all the way from read-only all the way up to basically admin or super user. There's also user, configurer. There's all sorts of different roles you can put in there. After you have this user accounts and these role-based access, you can then access the audit logging feature. And what that will do is, again, hypothetically, if there was an exposure or password leak or something, you could go in and search on the account that you think might be compromised, filter down on any sort of actions, and try to help you look through what happened over the course of that time to let you figure out, oh, it seems like over the weekend so-and-so did this, and you talk to them, oh, that wasn't me or whatnot. It helps you really kind of trace down exactly what's going on in your system and help you isolate possibly any exposure. So our SCADA Data Gateway is now run through a web browser, think like Google Chrome or Firefox or something like that. But it is worth pointing out that even though it is inside of a browser like that, it does not require internet access. We are really trying to take into consideration cybersecurity. And if you need to limit the access to your SCADA Data Gateway, and you don't want to obviously open that up to the World Wide Web, then you can access it through an intranet or local network. If you want to make it even more secure, you can actually set it up so your SCADA Data Gateway will only respond to specific IP addresses. So someone can't just bring their laptop in, plug it in, and start interacting with the SCADA Data Gateway. You can actually lock down which PCs are allowed to communicate with the SCADA Data Gateway. And of course, we have certificates. You can do third-party certificates for HTTPS. We have encryptions, all sorts of cybersecurity features for the SCADA Data Gateway. So this is going to be the last slide we'll be looking at today. I really want to give you kind of an overview of what Jackson will be going over. We are building up and putting the finishing touches on a configuration for our SCADA Data Gateway. You'll see that here in the middle is our SCADA Data Gateway. We'll be communicating with several things outside of the gateway, but the end goal is to have a 104 database, which we will publish information to our SCADA Master as a 6870-5-104. Everything here in red is our SCADA Data Gateway. This kind of gray, dark gray color will be simulated in DTM, and we'll also have an OPC UA server that we'll be interacting with. So the idea here is all of the data will need to come from these RTUs and this OPC UA server, and eventually be put into our gateway through 62850 clients, DNP3 masters, and obviously an OPC UA client. All of that information then through mapping, equations, anything like that will be concentrated into a single database and then published up to our SCADA Master. So at this point, I think I'm going to hand it back over to Beth, and I think quickly over to Jackson after that.
Okay, thanks, Matt. So I do just have one question that came through here. When you map between protocols like 62850, 870-5, 101, 104, or DNP3, are you following industry standards like IEEE 1815.1 or IEC 62850-80-1?
I might pass this one off to the panelist. I know that we try to follow standardizations, and some of obviously the more simple things like Boolean to Boolean, or you can do things like converting from shorts to floatings or whatnot. I know there are different ways you can do that way. As for those specific parts of the spec, I don't want to misspeak there, so I will pass that off to someone who may have a better answer or more accurate for the second half of that question.
Okay, well, we can address that one online as well, because I know we do have a lot to cover. So I'll leave it to the engineers working behind the scenes. And then with that, I'll pass it over to Jackson so he can start his part of the demo. Okay, Jackson, you should be presenter.
Sure. All right, just a moment. All right. Thank you, Beth, and thank you, Matt, as well, for that excellent introduction. So what I'm going to be doing today is really the live demonstration portion. And this is one of the last slides that we saw up on Matt's screen, and it's what I'm going to be configuring in our gateway, SDG or SCADA Data Gateway. So just to run through a little bit about what we're going to be doing, we've got the gateway here in the middle. At the bottom, we have our data that's coming in. So this will be an OPC UA server. So I'll have an OPC UA client within my gateway that's going to be receiving that data. I'll also have two DNP3 outstations that are sending data, and I'll have two DNP3 masters that are receiving that inside of my gateway. And then finally, I'll have two 62850 servers. Again, these at the bottom will all be outside devices, and then I'll be receiving that data inside my gateway. Of course, 62850 will be with a 62850 client. Finally, I'll be aggregating that data and providing it up to a remote SCADA master. So, of course, what this looks like for you is going to vary depending on what devices you have and what protocols you're using. But today I chose to use 6870-5-104, pretty common SCADA protocol, at least in certain parts of the world. And I'll be providing that data that I aggregate all together and then passing it back up. So I went ahead and did a little bit of the configuration ahead of time. So I have brought in one 61850 client, as well as one DNP3 master. But now we're going to be creating the rest of what we saw in that last diagram. So first, let's start out with 61850 client. So in order to do a lot of what I need to do today, I'm always going to be starting by right-clicking on the gateway root node. And you'll see there's a lot of different options here, right? So this is how I'm going to be adding different client and server communication devices. But in this case, I'll actually be going down to the 61850 section and adding a 61850 client. So the first thing I need to do is give it a name. I like to start with 61850, the protocol that I'll be using, whether it's a client or a server, master and outstation, depending on the protocol. And then finally, the device that I'm connecting to, its name. Next, 61850 is a little bit unique, at least compared to something like 104 or DNP, where it does have a model, some sort of file, that describes what that device contains. So there's a couple different ways we can get this model. One would be to actually do a discovery. So what we could do if we have our device, our IED, this D1 line 1 LPU available, then I could just fill in my communication settings, connect to it, and discover the data model that is on that device. But if I want to do more of a top-down engineering process, I already have the file for this device defined, then I can instead do build from file. So this might be a CID file for 61850, an individual capability or configured IED description for a file, or it could be an SCD, a substation configuration description. In this case, I'll be using an SCD. Now it is already uploaded into my gateway because I already did create that other device ahead of time, this BCU, from that same SCD, but otherwise I would just need to upload the file into the gateway. The next step is just selecting which of the multiple IEDs defined in this particular SCD file I want to create a client for. So again, if this was a CID, there might only be one, but because this is an SCD, it describes a whole substation and the many devices in it. So I'll just select the D1 line 1 LPU 1. So one of the cool things that this does for me, because the SCD file contains the communication settings for this device that I'll be connecting to, those are filled in automatically. So I see the IP address already filled in, as well as some other parameters as well, such as port. If I come down into our 7-layer stack setting, if you're more familiar with under the hood stuff of 61850, this might look familiar. Other security settings and things like that are all available down here at the bottom, depending on what you're using for your specific application, but we do support a host of security features. And with that, I'm ready to go ahead and just hit OK and create my 61850 client. But I'm not done there. All I've done so far is create that client server connection. So next, I need to start to bring data into my gateway that's available from the server that I'm connected to with this client. In order to do that, I right-click on this client that I just created, and I've got a couple different options again. So I could pull a particular data set or just even a particular point. But if I have done my top-down engineering process, I've created reports already on my device, or maybe even they just came pre-configured in my CID from the manufacturer, then I do have the option to just add a 61850 report control block. So in this particular case, this server that I'm connected to only has a single report control block, but if I did have multiple, each one would be listed here. And then once I pick one of the report control blocks on this device, down below, I can see what data is going to be available in that device. So this list here is really every data attribute that's contained in potentially every data object that is a part of this report. So because there's only one, I know this is the right one and this is the one that I want to add, but if there's multiple, I would use this list down here to tell which one I wanted to add, if not all. Okay, so now I've added this report. I mean, the report really already existed within the SCD file, but I've now made the gateway aware that I want to gather data out of that report, and I'm going to add some items to this report. So again, just to be clear, if you were to look in the SCD file for this particular device, you would see that report and you would see the data in it. What I'm doing here is really just the configuration. It's where I'm adding the data into my gateway of what was made available in that device. So I have a couple different options. This is all the data that's available on the device. Each row here represents a data attribute in the data set of this particular report control block. I can also see if the timestamp and quality is available, which in this case it is because they were included at the data object level. I could, just add some checks for individual ones that I want to add. Potentially, I could just do a filter, look down for, maybe I just know I want to add everything that ends in STVal, for example. But in this case, because I did do a top-down engineering design, I chose the data that I wanted to be in my reports. I chose the data that I wanted to be available to my gateway ahead of time for this express purpose. So really all I need to do is just check this top box up at the top. It'll go ahead and check everything for me. And when I hit OK, it'll add all of these data points into my gateway. So we've not yet mapped this to anything going out, but I'm getting a little ahead of myself. Before we start making this available or this data available up to my 104 SCADA Master, I want to go ahead and finish the other data that's coming in. So if we pull back up that picture that we looked at before, I effectively have two 61850 servers, and I'll kind of be working from right to left. We saw that I already have one DNP3 outstation, and I want to create a second. I already have one DNP3 master connecting to one outstation, but I want to create a second that connects to a second outstation, and that's what I'm going to be doing next. So to do that, much like I did before with my 61850 client, I'm going to right-click on the gateway root node. So we do group a couple different protocols together within this add TCP channel master. So I'll go ahead and click that, and that's how I'm going to create my DNP3 master. So I do need to specify that it is a DNP3 master from that dropdown. Like I said, we've lumped together 101, 103, 104, Modbus, and DNP. And then I need to give it a IP address of the outstation that I want to connect to. So in this case, I know that this will be 10.10.10.153. And then I know that my port number is going to be 20,001. My local IP I can leave for default right now. If I have multiple IPs on my machine, I could choose one that I want to bind to for my outgoing connection. But for right now, I can just leave that at the default. And lastly, I do need to give a name to my connection that I'm going to be adding, my DNP3 master. So it looks like it saved the names that I've given recently. So I'll go ahead and choose the DNP master 2 to kind of complement the DNP master 1 that I already have. All right, a couple more settings that I have the option to look at. Some security settings down here. Depending on what your particular setup is and what level of security you're looking for, you do have those options. I'm going to give it a session name, otherwise it would just choose the default. And then, yeah, again, just other communication settings. In this case, I can leave everything by default and just go ahead and hit OK. So this is where I would add the types of data points that I want to be read into my DNP3 master. Now there's a couple different options, different ways I could handle this. So I could do a discovery, so auto create tags. So if I have my DNP3 outstation out there and available on the network, then it'll go out and do a discovery and say, okay, what types of points exist on this device? It'll do kind of a general polling of everything that's out there and create the appropriate tags here in my DNP3 master. And there's some cases where that might be exactly what I want to do. But in some other cases, I might not actually have that DNP3 outstation available and on the network while I am configuring that gateway. And this is a pretty common, you might be configuring the gateway at your desk before you get out into the field and actually have it installed and all devices available. So we do have some options as well. I could basically create the points manually. And I don't know about you, but when I create points manually, I always like to give my points intelligent names. And that's what I've done up here ahead of time on DNP Master 1. So you can see that I've used alias names such as line 1 breaker 1 position, or FTO might indicate fail to open, fail to close, or just maybe more general alarm. And I have this for each breaker that I might have. Let's say I have 5 breakers in this particular bay or line. So now I want to leverage this information that I've already created. I've already taken the time to create my 25 binary inputs and my 25 analog inputs with intelligent names. And I want to apply these that I've already done from DNP Master 1 and use them as sort of a template for creating the necessary points using the same names or maybe slightly modified names in my master 2 that I've just created. So good news, this is pretty easy to do. In order to do that, I just need to right click on the device itself, so DNP Master 1, and I'm going to export the points. So I do need to make sure that I say recursive include children, and that's just because session as well as the point types, binary inputs, and analog outputs are children of the root, which is the DNP Master 1 device. And I'll just go ahead and hit export. When I do that, it exports the file out to my downloads folder, and I can just right click and open that up in Notepad++. And now we see a nice overview, kind of a, really, it is a CSV view of what's available inside of that points list. So we do see the user tag name. This is going to correspond with the alias name, the intelligent name that I gave the point, versus the tag name, which is really just the device, the session, the point type, T1, of course, corresponding to binary input in DNP, and then P0, the index. So to update this for my second DNP master, I'm just going to do a basic find and replace master 1 with master 2. See, we've done 50 occurrences. That all sounds good because I have 50 points, 25 of each. And then finally, because this is my master 2, and let's say that it might be in Bay 2 as opposed to Bay 1, I'm going to change line 1 to line 2. And I should get, I believe, 100 of these because I have both a user tag name as well as a description. Correct, 100 occurrences, all good there. And then I'll just go ahead and give this a save, and I'll name it DNP Master Points 2. And now I am ready to upload this back into my gateway and apply these points that I've just edited to my DNP Master 2 device that I created. In order to do that, I just right click up on my gateway root node, and I want to select the import export points option. I click that, make sure that I select import points. I'm not exporting anymore. And then I just need to select my file. Find that point that I just created, DNP Master Points 2, which is a modified version of 1. Just hit OK. And sure enough, I see that it has created 50 points for me. So I can just close this out, give my gateway a refresh just to bring in the updated point types. And sure enough, session binary inputs, if I click on that, I can see that I've created those 25 points with the intelligent names that I took the time to apply for DNP Master 1, and now they've been applied down here to DNP Master 2. All right, so we're still not quite ready to begin passing data up to my 104 master. I still need to bring in data from my OPC UA server. So just a quick word before I start doing that. Everything we have brought in thus far into Gateway has been brought into an internal OPC UA server, which is what you see here. The mapping is really done automatically. So if I did have a local HMI or something like that that needed to read data from my gateway via OPC, that work has already been done. But every time I bring in a point from one of these 61850 devices or DNP devices, I am adding it to a local OPC UA server. That's great, but a lot of times we also have customers that want to bring in data from an external OPC server. And in this case, we do need a local OPC UA client. So that's pretty easy to do, much like I did for my DNP and 61850 devices. I start by right-clicking on the gateway root node. Now, again, I'll skip over the TCP channel section as well as the 61850 channel section, and instead I'll come to the OPC UA area right here in the middle. Well, I shouldn't say UA. There's OPC Classic up here at the top, AE, Alarms and Events, and then UA is what I'll be using today. So I'll add an OPC UA client. And just like before, the first thing I'm going to need to do is give it a name. So I like basic names, so I'll just start with OPC UA client. Now, instead of a IP address like we typically have for maybe DNP or 61850 or something like that, I need to provide a URL, which is similar to an IP, but it includes other information as well. So I'll just open up my OPC server that I have running in the background, copy the URL out of that and paste it in. All right, so again, kind of like the other protocols, depending on my particular device and what security settings I may or may not be using, I am already done in my case. If you are using some sort of authentication or advanced security settings, you'll need to set that up here with your certificate files, private keys, so on and so forth. But in my case, I'm just using the basics, so I can just go ahead and hit OK, and I have created my OPC client. I'm sorry, did I name it OPC UA server? Which one is this? Sorry guys. Okay, here we go. So I named my OPC UA client OPC. So now it's time to start adding items to my OPC UA client. Now there's a couple different ways to do this. I can add individual points or multiple points, but either way that I choose, one of the nice things about OPC UA or OPC in general is that it is a browsable protocol. So I don't need to memorize point lists or even provide a configuration file. I can just click and add and browse my device, assuming it is available and connected, and see what data points are available on it. So in this case, on my OPC server that I've created just for this demo, I created a folder called Substation OPC that has a bunch of different data in it, including an object called voltages that itself contains 10 children elements named voltage 1 through voltage 10. So I created it for the purpose of adding it all to my OPC client. So I'm just going to go ahead and check all and just say add items. Sure enough, when I did that, it has added the 30 items that I created. I can now close out of this and come down, and we'll see that I've added a folder called Substation OPC underneath my OPC client. If I click on that folder, I can see the different points that were available at that root level of the folder right there within Substation OPC. And then, as I mentioned, I had created another object, in some ways like a folder, within that Substation OPC folder called voltages. I see that appear as a child of Substation OPC, and then down below, if I click on it, then I can see the 10 different voltages that are inside of that particular object. Again, I call them voltages. They're really just floating point numbers that could represent any data. But we, of course, have floating points, binaries, strings, so on and so forth, common OPC UA data types. All right, so at this point, we have brought in all of our data. If I bring back up our picture one last time, we'll see we have our OPC UA server, our DNP outstations, and our 61850 servers, all existing down here at the bottom. We've created their companions within our SCADA Data Gateway. That would be the OPC client, the DNP3 masters, and the 61850 client. So now it's time to begin passing our data, and if we choose, manipulating it before we do, up to our 104 master. But before I do that, I do want to pause for a quick minute and talk to Beth. Beth, do we have time to stop for questions?
I have time for one question because we're a little tight, but let's get this one in. And Matt, I believe this is a question for you. So during protocol conversion, is there a chance that we lose some information such as time stamping accuracy and quality information?
So it really depends on what you're mapping to and from. Obviously, each protocol has its own unique way of storing data and its own unique way specifically for qualities that they want to handle quality. So maybe one protocol will have a quality for something that doesn't necessarily one-to-one match up with something in a different one. But we have various ways, and this kind of goes back to the 20 years we've been working with our customers of automatically setting up these conversions for you. Of course, you can go in and specify things through equations, which Jackson will go on a little bit later. So I would say, you could get a perfect one-to-one, especially for data values and stuff. You may not lose any sort of significant values or significant digits. Or maybe if your data types are slightly different, you might lose a little bit. So it really depends on how you set it up. And as for qualities and timestamps, we can map those over as well. And there are several different processes that you can follow to basically try to figure out what is a like quality to a like quality in a different protocol.
Okay, great. Thanks, Matt. Jackson, I'm going to hand it back to you, and you do have the rest of the hour.
Okay, excellent. All right, so where we left off, we have all of our data coming in, and we're now ready to create our 104 SCADA Master and begin mapping data up to it. So just like I did for OPC and DNP3 and 61850, in order to create that 104, well, really, I need to create a 104, I believe the term is in 104 controlled station, but you could call it an outstation slave, depending on the protocol. The terminology changes, server for 61850. So in order to do that, I'm going to come back in here, and just like I created my DNP master by clicking Add TCP Channel Master, in this case, I'll click Add TCP Outstation Slave. So I do need to specify that this is 104 in particular, and then I do want to give it an IP address. So I could just keep with localhost, but in this case, I'll go ahead and do 10.10.10.154. So I do want to point out that I need to have this IP address available on my machine. So I have ahead of time gone in and added this as an available IP on my machine. The gateway won't do that for you. You need to make sure you do that externally. But you can also just use localhost and it'll bind to whatever the local IP is. So for a channel name, again, it just seems to be remembering the names that I used in my trial run here. I'll go with 104 outstation to SCADA. Again, 104 indicating the protocol, outstation, just clarifying that the data is coming out of this device, and then it's being passed up to my remote SCADA system. And then lastly, let's see, the rest of these settings I can keep as default. And then I just need to, just click through. I can keep these the same depending on my security parameters. You might need to mess with them on your particular device, but for myself right now, everything is good. So now I have the opportunity to add what type of data I'm going to be sending out of my 104 outstation. So, here's the list of available options. So T just indicates the type, and then you'd really need to get familiar with the 104 documentation to know the number. T1 corresponds to single point, whereas maybe T13 would be floating point. We'll be working with both of those, as well as once we get into the controls portion, T45 single command. So I'll go ahead and start out by adding single points. And then additionally, I also want to make sure that I add in those T13 measured values as well. Okay, so now basically what I've done is I've configured this device, I've assigned it an IP address, and I've let it know what types of data I'll be sending out of it. But now I need to map that data over. So, since I already created my single points down here, now I can come down to, let's say, for example, my DNP master, find my binary inputs, the equivalent on a 61850 device, and I can begin to map my data from my DNP master 1 up to my 104 outstation. So, we, of course, can basically just hold shift and click, select all of my DNP points, and click and drag them up to my 104 master. Now, when I do this, it basically defaults to the first available point. So P1 is the first available point on my 104 master that's unused within the T1 type. So that's going to be the single point. And it just continues increments from there, and it chooses the maps, or it chooses the point numbers or indexes on the outgoing side. Now, I could manually come in and overwrite this if I had a particular point that I wanted this to map to, but in this case, I'm going to let the tool do the work for me and just do the mappings for me. So I can just hit OK. I get affirmation that it has in fact worked. Now I could do the same thing for, for example, DNP Master 2, come in here, take all of my binary inputs and also map them up as well. Again, now you'll notice 1 through 25 were my initial 25 points. The next available index is going to be 26. So my DNP master session 2 T1 P0, which is my line 2 breaker position, is going to be mapped on the outgoing side, the 104 side, to P26 of the same type 1. Hit OK, and that is completed. All right, so I could go through the rest of these and show you what the mapping looks like, but I think that's a little bit dry. So I will point out that there's another way to do this as well. So I think in general, clicking and dragging is pretty easy. And if you don't care what point your data is mapped to, like if I'm fine with the fact that my DNP P0 is mapped to my 104 side P1, this is probably the quickest and easiest way to do it. But if I do have a pre-existing data map that defines the functionality of my gateway and how it should be working, I do have an alternative that I just want to make sure everyone is aware of. So it could be tedious to come in and manually update where these mappings are, kind of point A to point B, like I just showed a moment ago, to do it here within the tool. So that alternative method would be to import a mapping file. So this is going to look a lot like what we just saw before when I was importing and exporting points. Whereas importing mappings, instead of just creating the points on a particular device, they clarify where on the other device the point needs to be connected to. So again, if you have some sort of spreadsheet, let's say, that defines the functionality of your gateway, what data needs to be available at what point, then you can leverage something like Excel and maybe export some initial mappings, take the mappings that you have in that descriptor file and kind of merge them into Excel and create the mapping for an entire gateway in there, and then just have it imported back up here. And again, that's particularly useful if you already have that documentation that defines how your gateway should work and what points need to be mapped where. So a couple more things that I do want to make sure I highlight. One of those would be what happens when we have more complex mappings. You know, let's say that if I come back down here to my DNP device and I've got all of these different alarms that are coming in. Let's say breaker 1 alarm for this breaker, and then I have another alarm for another breaker, so on and so forth. What if that's the data that's provided to me from the DNP side, but by the time I pass it up to my SCADA, I want to kind of OR those together, aggregate them, if you will, into a single point using something like a multiplexer. Well, that can be done within the gateway and a lot more using equations. So equations are kind of a complex point type that allow you to operate using logic. So in order to create one, just like everything else, start at the gateway root node, right click, and say add equation MDO. I'll just give this one a name, alarm combiner. How about that? And then over here in the MDO filter, I'm gonna be looking for every point that's available in my gateway, finding it, and then adding it down to this expression builder down here at the bottom. So I mentioned P4. So P4 was the alarm on DNP Master 1, Breaker 1. So I'll just go ahead and collect that. And then what I want to do is OR it together, you know, with another point. And if either one of those is true, then I want my combined alarm to be true as well. So I've got a lot of different logic operators that I can do down here. I can do some pretty complex things. You know, this could go anywhere from basic ORing together, you know, like I'm doing today, or some fairly sophisticated control. But for right now, I'll just stick with an OR, which would be this operator, a bitwise OR, and then I'll OR it together with the same equivalent alarm in Bay 2, which is going to be DNP Master 2 P1 P4. No, I'm sorry, it looks like I already added that one. I'll OR together with Master 1. So the same point on two different devices from two different bays. If either one of those alarms becomes true, then the alarm will become active. So I always want to make sure I validate my expression, just make sure that I didn't have any typos, and sure enough, everything's good, and I can hit OK. Let's say I might want to have another, just to give you another example of the type of equation you could do. Maybe I want to do some scaling. I want to convert my kilowatts, for example, that's coming into I believe this is also T4, but in the, I'm sorry, P4, but in the type 30, which of course is my analog inputs. So this is going to be my kilowatts value that's passing through a specific breaker. I could just take that, divide it by 1,000, and that'll let me know how many megawatts I have passing through this particular device as opposed to the kilowatts that I'm getting. Again, just a basic example, but just to give you an idea of what's possible using equations. Validate my equation again, make sure that everything's good, and sure enough it is, and I can just hit OK. Now, if I do want to have somewhere to keep these, you'll notice that my equations are in this root node. I can create a folder and keep those equations there, and that's what I typically like to do. So just add a user-defined folder, call it equations, hit OK, and now this will appear in the tree, and I can take these points and drag them over to my equations folder, and just makes it a little bit easier to keep track of them. Now, if I want to take one of these and map it up to my 104 outstation, for example, I easily can. So that alarm combiner that we talked about before, just take it and drag it to T1. Next available point is going to be 51, so just hit OK, and we are good to go there. So now I've finished configuring my all of my data being mapped. I've taken some points and combined them into a single point. The last thing I want to do is make sure that I have controls mapped correctly from my 104 master down to my 61850 device. So this kind of similar to how we added that report control block at the beginning. I'm just going to right click and add a control point set. So this is where I'm going to be putting all of my 61850 controls on this particular device. Again, they already exist on the device. I'm just creating almost a folder, if you will, to keep track of the ones that I'm interested in. So I right click on that controls folder, and now I can see everything that's controllable on this particular device. What I'm particularly interested in working with today would be the QA1 CSWY1 position. So this is going to be operated with select before operate with enhanced security. So I'll just hit OK and add that there. So now I've brought the control into the gateway. I need to map it to the equivalent place on my 104 side in order to make sure that it's available from SCADA. To do that, I just need to right click and add the appropriate data type. I alluded to it earlier, but T45, our single command, will pair nicely with this select before operate position value. Just hit OK. And then now I come back down to my control and click and drag that point up there. You have different options available. You know, in this particular case, the default's going to be good enough for me, so I can just go ahead and hit OK, and it will map that control for me. I now can operate this breaker from 104 using that single point command. So lastly, special views, just a couple other things I want to point out. I have not created any alarms or warnings, but if I did have a device disconnected or something like that, warnings would be available here in the special views. Typically, the way I think about it is health and performance are always there, always static. Now, if any of these values are in error, then I will see something in the warning. So for example, let's just say channel online status or maybe offline counter. Right now I have 0 devices offline. If this was 1, for example, indicating that I did have a device online, it would be available in my warnings. Now I also might want to map this value up to my 104 side. Just give me some diagnostic information to let the SCADA side know how the gateway is performing. Easy to do. I just take that counter and drag it over to, for example, the measured values. So with that, last thing I do want to point out would be how do we log things that are happening in our gateway? A couple different ways that this can be done. One example would be using our sequence of events logs. So there's a kind of a global setting. If I right click at the top root level node and I edit the workspace parameters, using this I can edit the global sequence of events log mask. So here we see different categories on the left side. If I hover over a particular mask, then I can see the data that's available, or really the triggers that are available within that category that will trigger something to be saved within the sequence of events log. So like a basic one, for example, if I come down here to diagnostic, I could see the data is being updated because it was requested, but the request was unknown, for example, but the reason is unknown. That might be a valid reason for me to want to record that data in my database. Let's say I didn't want to do it at a global level, and I was really only interested in capturing individual points and their changes in my sequence of events log. I do have that option for that granularity as well. So coming back down to, for example, this DMP point, let's say that I wanted to trigger a recording every time that the breaker position changed. I could come over here, click my pencil to edit this particular point, click on the pencil again to get to the options, and we'll see that I actually already have that setting turned on. Here in the log mask, update change indicated. The source of the data indicates that this update was a change. That, of course, will be recorded in the sequence of events log. And I can then view that later to give me an idea of what happened and when in my gateway. So finally, before I turn this back over to Beth, I do just want to give us a chance to see what this would look like in operation. Basically, I can come over here. I'm using DTM or Distributed Task Manager to simulate all the devices that I have over here in my gateway tree. So I'm just going to go ahead and toggle one of those points. So let's just say, for example, I'll just change the first point in my DNP master 1. Let's just change this from off to on. So when I do that, we're going to see that value be passed through the value change from off to on up here in my my gateway. That, of course, will be passed up to the 104 side where I can see it reflected here. The values being sent. Additionally, because I have my equation, my alarm combiner, I guess that would be a different point. I need to do that for 0.4. Then my alarm combiner will come true as well in just a moment once that equation evaluates. So with that, I'm going to go ahead and turn it back over to Beth. I hope this has been informative. I hope you guys have a better idea of how our gateway can be quickly and easily configured and some of the advanced tips and tricks that'll make that easier. Thank you so much.
Okay, well, thanks, Jackson. I'm going to go ahead and just take the screen and wrap up with a couple of final thoughts real quick. Okay, so again, thanks everyone for attending our webinar. Thank you for your time today. I do just want to point out, if you haven't already signed up, please go to our website and sign up for updates on our upcoming webinars, any future trainings that we're hosting, any product releases. It's right there on our homepage. When you sign off of this webinar today, you will be presented with a survey. It only takes 2 minutes. We really appreciate your feedback. This is also where, if you need a certificate for a PDH hour, the professional development hours, you can check off yes on that, and we will email you a certificate. The recording for this webinar will be posted on our homepage as well, probably by the end of this week, if not early next week. You should also receive a follow-up email directly from GoToWebinar if you fill out the survey with a link to the recording. So please, if you'd like to revisit it for just a review of what we went over here today, that's your best way to do that. And then, of course, any questions that you have or any comments, you can always email us at sales@trianglemicroworks.com. So with that, we do have a couple of questions that have come in while Jackson was presented, so I'll just kind of take those from the top. And I believe this first one is going to be from Matt. How do you organize individual data points from, for example, DNP3 and Modbus to form data objects, logical nodes required by IEC 61850?
So you can provide a SCL file, such as an ICD file, SCD file, as we saw today during the demonstration, to give the model that 61850 supports to our SCADA Data Gateway. From there, it's just like the mapping that Jackson did today. You would just grab points from things like your databases, such as your DNP3 or your Modbus, and add that over to the model and link that to a data attribute or data object. I think we even saw a little bit of this when we were talking about controls. So that's how you would normally integrate between the two different kind of models of the protocols. One being, a model-based 61850 or TASI2, and the other being DNP3, Modbus, 101, 104, etc.
Okay. The next question, how do you access attributes of a data point? I think I'm going to give that one to you, Matt.
Sorry, I was answering another question. How do you access the data attributes?
Yes.
Of a data point? So all you really need to do, and we've seen this a few times, you just go into the GUI for our SCADA Data Gateway. You go to the device that you're interested in, so that I think we saw today that you could add, say, a DNP3 master. From there, you just create the data type folder and then add the data attributes, or you could do auto create tags. However, get that data into the SCADA Data Gateway, and then you can access the data right then and there. Just make sure you set up action masks to keep that information live. So you can do polling every second or unsolicited messages, enable reports, whatever to keep that information live and accurate. And then you have access to it to use that in equations or mappings or anything along those lines.
Okay. I have another question I guess I'll just put out to the group. You now have the IEC 62850 data model that is built based on the data sources we have, but all these data sources are dynamically selected. Is there any way to provide the SCL file?
I'm not sure that I 100% understand the question. So it is true that when I was doing the 62850 configuration of the 62850 client, I had two options. I could load my client based on a discovery. So if I had the 62850 server online and on the network and configured, I could discover the data model for that device. The other option would be to provide the SCL file, which describes that device. Could be a CID, in some cases even an ICD, definitely a CID, and load that into the gateway. And that gives me the data model for the device, as well as what reports are available, what data sets are in those reports, what capabilities the device has, so on and so forth. So from that perspective, yes, we are able to use the SCL file. I'm not certain that answers the question, though. I just don't know if I understood it well.
Okay, Matt, did you want to add anything? I know you answered it online.
No, I think that's fine.
Okay. So next question, on what hardware and operating system does the gateway run?
Gateway runs on both Windows as well as Linux. Hardware, we do provide a substation hardened PC, which the gateway can run on, Linux variety, but you can also bring your own as well, and that is commonly done. It's really just up to you. We've seen people run these in the cloud on, a totally cloud-based machine, or something as small as a Raspberry Pi.
Okay. Well, I think that does conclude our question and answer session. Again, I'd like to thank everyone for their time today. And please be on the lookout for the recording to this and for our next webinar. Thanks, everyone.